So remember how every time we were going to take the antiderivative, we always had to put plus c, because when you take the derivative of a constant, you get a 0, and therefore there's no way of knowing what that constant was. Well, here's an example of how we can find the constant. They give us the function that the derivative has been taken of, right? Because look, it says f prime of x is x to the 2/3. The derivative was taken. Now we're going to go backwards to find the original function, so that's the integral of that, and the dx indicating a derivative was taken. So this is the antiderivative we have to do. Don't forget your dx. Now we're given some information, but to find, remember this is this guy in here, right? This part in here, that's the derivative. So that's the f prime. We want to go backwards to f. So this is what f is. This is f of x. It's the integral of all this stuff, right? This is f of x. Okay? We got to take that, and then we know some information about f. We know this point, 1/3 is on f, not on f prime, but on f. So let's do our antiderivative. X to the 2/3 plus 1 divided by 2/3 plus 1 plus c. So right now we still don't know, but we know this is the formula for f, the original function. So, and you could call that f of x, you could call it y, either one. The original function is x to the 5/3, right? 2/3 plus 3/3. 3/3 is 1, gives me 5/3. Divided by 5/3 plus c, and we don't want to leave this with this 5/3. We want to write it as f of x or y. Original function, in other words, original function is 3/5, because when you divide by a fraction, you multiply by the reciprocal, x to the 5/3 plus c. And so now you're saying, well, how do we find the c? Well, we know an x and a y. So y is the output, or the f of x value, so we put 3/5 here, and we put 1 here, so 1 to the 5/3 plus c, and 3/5 times 1 to any power is just going to be 3/5. So 3/5 is 3/5 plus c. So in this case, c is 0. It doesn't always come out to be 0, okay? But because our constant is 0, we don't have to write the constant. So this is just 3/5 x to the 5/3. So 3/5 x to the 5/3. No need to write plus c. We found that c is a 0. So this guy's zeroed out. We don't even need him here. Okay, so here's another one where they give us the slope of the tangent, okay? That's the derivative has been taken. They want us to find the original function, but we also have a point. So to get from f prime to f, we have to do the antiderivative, or the integral. So integral symbol always comes with a dx, 6x negative 6/7. Okay, bring the 6 down, because it can come outside, right? Add 1 to the exponent, divide by that negative 6/7 plus 1, and then add a plus c, because we don't know yet what the constant is. Negative 6/7 plus 1 is negative 6/7 plus 7/7, so that's a 1/7. Okay, so that's 6x to the 1/7 over 1/7 plus c. And since this is dividing by fraction, that gets flipped over. 7 over 1 times 6x to the 1/7 plus c. So that's 42x to the 1/7 plus c. So this is the integral with the constant unknown, but we know more information about this function. We know that for this function, so if we say this is y, or f of x is 42x to the 1/7 plus c, and remember f of x and y are the same thing, we can plug in our y, which is -9. It's 42 times -1 to the 1/7 power plus c. And we got to figure out what this -1 to the 1/7 is. Well, that means the 7th root of -1 to the 1. So that's the 7th root of -1. That's just going to be -1. So -9 is 42 times -1, -42 plus c. Add 42 to both sides, and 42 subtract 9 is 33. So c is 33, right? So if we do this here, we get 33 is our c. So instead of having this plus c up here, we can now replace that c with a 33. So this is the function whose derivative was taken to get this 6x to the -7th that also goes through this. Okay, so that is 42x to the 1/7 plus 33. Plus 33. Make sure that's not in the exponent.